Yeah, dear friends, today the whole podcast will be dedicated to data. We're living in an age where computer system, mobile, all kind of applications dominating our world, and we love and use some on a daily basis. But we tend to forget that beneath every successful application, there is a data and the data bank. So I will start with evolution of data bank. But before I move on, I would love to greet Artem Demchenkov, my guest today, as an expert in all things related and connected to data. Hi, Artem.
Hi, Sergey. Thank you for inviting. Happy to be here and talk about data. Exactly. That's my passion, and that's exactly my full-time responsibility nowadays.
Right, we're gonna come back to exciting, challenging things that you're building with your company, but to give a perspective to data evolution or evolution of data banks, it goes back to modern evolution of computers. So in 1960, the Charles Bachman built first commercial database that was used in General Electric. So General Electric, to all of my American friends, was the company that was in US, like pretty much every electric appliance was built by General Electric, and now they almost fade out of the business. Like things happened. Uh, but through the start of relational databases, which we all use, and for all my developers around, like Postgres is a good example, uh, the credit was given to Edgar in his paper of relational model of data for large shared data banks. So he coined the term data banks, since we use like for data banks as now, like we actually write it together, but before it was written data and then banks. Um, so 1960, 1970, just to give you perspective, 1961, the first man in space, Yuri Gagarin, flew around the orbit and safely landed. 1977, Voyager mission. So that technology with very primitive databases was used and still operational. Like 45 years later, it's still operational. Left this uh, stellar system and sends the signals back. I'm really humbled, and I'm really thankful to our grandmas and grandpas for building that. And moving forward, like the data started to get maturity, computer system get in our homes. 1984, release of the first MacBook or Macintosh. Back then we didn't call it Macs. um, why I call it my days, because I was born in 80, so it's the time where I could relate. My blood was already touching some data. So Mac was the first Mac was had 128 kilobytes of RAM. And if you look at your modern computers, what we like MacBooks Pros and MacBooks, what we use, will the 16 gigabyte of RAM is kind of standard. So it right now we have a processing power for the RAM. So basically, operating of your databases is 130,000 times faster. Yet still, the technology that was built in 70s operational and sending signals to Earth from the outer stellar ring. And I would love to, Artyom, look at your view. Why this happened? Like, where are we going? What influences evolution of databases and data? Let's mingle about that.
Yeah, you know what just came to my mind when you spoke about this nice history of data. Um, Back then, when it was a Voyager's mission and other space missions, every single use of data was a real rocket science, although it was not really that powerful databases as we know nowadays. But every single use case was a real rocket science, and it was doing an actual job. And nowadays, data storages are much cheaper. They are much more uh, reliable and available to people. But the majority of use cases are still very primitive. And I would say the development of these use cases is exactly the driver of this evolution. Um, that's why, for example, if you compare the past and where we are at the moment, in the past, we didn't have ETL processes, we didn't have data warehouses, we didn't have business intelligence, we didn't have data science, big data, and every single birth of these technologies was spreading out an enormous number of new use cases and gave birth to the next generation of technologies itself.
Artem, so if we look back and the first website, so the first HTML website, probably without even CSS, it was
Mhm.
just the business card. So we could only see the data. What happens after that?
Yeah, exactly. The main idea of the first websites for businesses was to demonstrate a phone and an address of the company and basically get customers on the phone and then keep selling online as it always was for decades. And step by step, so when I was, for example, when I was starting to build my first website as a webmaster, as it used to be called back then, it was the end of 2007, 2006, even something like this. The majority of customers who came to our studio, they just needed a very simple 2-3 pages and then a phone number there, although it was already quite a modern era of internet and quite a modern era of computers. But step by step, people realize that the actual power is not in presenting your phone number to customers. The actual power is in the product-led growth, when your customers naturally work with your website and interact with it, and that's how you do business. Even if your business is fully offline company, it still happens through your website. And then they naturally started to collect more data about their customers. They started to track their location, they started to track their preferences, IP addresses, they started to use cookies, they started to use such products as Google Analytics, Segment, and so on and so on. And of course, the amount of data that was typically stored for such websites started to grow dramatically, and completely new technologies became needed to actually operate with this data. And that what basically started the era of such products as business intelligence like Tableau, uh, Looker, and others. And that's basically how the modern era of data products started.
Artyom, and I love to intertwine this story. So your your first websites, you were working in 2007 as a web administrator. That's how we called it, or but so the first social networks were just started to be like really popular. So I think Facebook
Mhm.
was launched 2004, but really took off a couple of years later. So the amount of data that started to aggregate around usage and users specifically were so huge that obviously the standard relational database was not enough. So I remember then the new coined terms graph databases
Mhm.
came into place, because you've not only looked at relational database but no relational databases. But also in 2009 we've seen birth of blockchain. So Bitcoin was released, and this is started like an era of um, I don't know how it's like the blockchain is the whole thing of a new set of databases. This is where the sharding was introduced, basically ability to split your different databases into units and nodes, and then being able to communicate through them with shards, so that you increase time of indexing information on each block.
Yeah. Yeah.
Um, and right now, like I don't know, I just 2 days ago, I was at the party. Our friend Andres Ayarne, he built a company. It's called Quadrant. So it's a Berlin-based vector similarity search database. So yet another loop of innovation where not only you're able to index but create a vector of similarity and like to predict the same thing, this like in the same analogy as large language model, you predict the next word. There you could predict a recommendation for search for best similar item, etc., etc. And I like if I look back to your story, like it's all going with the usage and the user in the middle. So like just to keep you as a sparring partner, where are we going? Like how crazy it will get in the next couple of years?
Yeah, that's an interesting example that you used regarding this recommendations and similarity, because exactly the same task we've been solving for one of our customers back in 2011. And it's interesting that this problem is not yet completely solved. If new startups keep appearing in this industry, keep being born in this industry. And that's also a part of the story. So basically, when I look at the current market, and as currently as a founder of a data company, I need to be up to date with the current market situation. I need to know the competitive landscape. I need to speak to investors about it. I need to be really up to date there. And I see a lot of products that are kind of, let's say, two types of modern products, two directions. The first direction is artificial intelligence oriented, pretty new. There is a lot of innovations. There are a lot of use cases trying to really bring natural language processing and, in general, AI into the daily life of customers. And there is also a direction where people constantly try to improve and try to reinvent what was already invented before. Reinvent in a good term. So basically, to rebuild or to improve the need of something that was actually invented long time ago, but with the new level of technologies like blockchain, as you said, for example, it brings the new abilities that people didn't have in the past. And here exactly this graph search of recommendations or relations is one of such examples. Like to give another example here, I was a couple of years ago, I was on a Google conference in München, and there was one speaker who was involved into the Panama Papers investigation. And he said that it was a huge, they received basically a huge number of these papers, and they needed to build a lot of relations between different companies and different people in order to actually understand who is involved into which business. And of course, if you look back like 20 or 30 years ago, it's supposed to be a completely manual process. But nowadays, with the help of graph databases or distributed databases, it's much easier, because as soon as you scan these documents with OCR, you have data, and then you upload it into relational into graph databases, and they can do a lot of work for you automatically, and it speeded up the process dramatically, of course. So that's why I would say we are going into two directions like this. One direction is completely different innovations, something that never existed before, and the second one is a constant improvement of something that was already invented, but with the raise in level of technologies, it's possible to make it much faster and more reliable and cheaper, of course, which is also a huge factor.
Artem, I was quite impressed when I saw a post about your one of your next product features, but it blew my
Mhm.
mind. I've looked at the practical application what you've done with the company, with the team, and just to throw like a bomb, but you really integrated chat GPT option, but not just chat GPT, but leveraging the ability to use that function into data modeling. Like at least when I saw it, I was like, Jesus, like this cleans up my data without like, touching up. I could like, literally uh, talk to my um, language model. Okay, now import, cleans it up, turn it into a different format. In my reality, it takes sometimes weeks actually to come across that and take a decision. You've done it just like that. Could you just, share with us, like, how did it come about and the difficulties and the future that might bring with this feature?
Yeah, that's. I also see it as a completely mind-blowing experience, because with the introduction of ChatGPT in general, um, it's still an early stage, and people are still playing with it and trying to understand how to integrate it into their daily routines, professional daily routines. Especially, there is a huge concern about data privacy, data protection, what you can share with ChatGPT, what you should not share with it. But exactly what we've done, we integrated it into our product, and our product is, to give a bit more context, is a data driven workflows for primarily operational tasks. So our primary customers are non-technical people who are not working with such things as Python or SQL in their daily routines, but they have a lot of work related to data operations. Specifically fintech operations is a good example. And when I saw in general a lot of posts in LinkedIn what ChatGPT can do with data, I naturally came to this idea that definitely it's something that we should integrate into our product as well. To give a simple example, like if we take fintech operations, and I know quite a lot and I talk quite a lot about it because I spent almost 8 years working in fintech as an engineering lead, and later as a technical co-founder of a fintech company. Um, I know that operations always work with broken or inconsistent data. And these data in fintech, they are broken or inconsistent primarily because it's coming from third-party data providers. And when you pull data from such third-party data providers like scoring agencies, credit history providers, open banking KPIs, you have to rely on it. You don't have any other choice. You get what you get. And then you need to use this data for your operational processes, decision making. And if this data is incomplete, you are basically stuck because you need to somehow find this data manually. So, to give an example, in one of my previous fintech companies, we um, we needed such a simple thing as an address of a customer, or not a customer, but a customer of our customer. So basically, the only thing to get it was to pull it from from credit scoring provider, and it was quite a common use case that we got it without a postal code, just an address without a postal code. We called the credit scoring provider and asked them, why is it so? Why is it coming without a postal code? They said, sorry, this is the data that we get. We cannot do anything with it, unfortunately. We built a workaround. We built an integration with Google Maps, and then we just sent what we had, like a street and a house number and a city, to Google Maps. And if we were lucky enough, they sent us back a postal code via API. But it still was not 100% working solution, because uh, quite a lot, it was just sending back a few addresses, a few postal codes, because it was quite similar addresses. Um, Again, like if you look at the address of the rocket tower, it's Charlottenstrasse 4 or 6. It's 4. Yeah, Charlottenstrasse 4. So basically, you will be probably surprised, but there are two Charlottenstrasse 4s in Berlin. One is in basically where Rocket Tower is located. Another one is near Wannsee, and it's also Berlin, and it's also Charlottenstrasse 4. Imagine that we don't get a postal code for this address and we send it to Google, then we get back two addresses, and we need to manually decide which one is it. So with ChatGPT, this problem solved instantly, because all of this thinking and all of this manual work, which addresses it, what is the postal code, ChatGPT already does for you. You just send this address to them and get back a postal code, and then your data is completed. So and can be used further in your operational processes. So that's one of the examples, of, of the thousands of examples how it can naturally help in operational life of companies. And this is just the beginning, because uh, as soon as a problem with data security is solved, and you can at some point start using ChatGPT on your local instances without sharing this data with OpenAI, then there will be even more use cases and even more examples that will basically help with automating daily manual routines of operational people.
Artem, I really love to linger about like this importance of data. And just to quote a friend of mine, George, he's our head of data. He's like, in every conversation, if you don't bring data, you're just guy with an opinion, and nobody wants to listen to you. But at the same, like, we believe data should be the central point in our lives, and especially in business. But very few companies take it seriously. Like your good example, like, what is our single source of truth? Every company I've been working with, it has like a dispersed version of the single source of truth. If you could walk us through, if you would start another company, you and me, we're just like about to start a new startup. How should we start structure a data? What should be a single source of truth, and how should we handle with all these secondary data providers? I don't know, like integrations with Salesforce, et cetera, et cetera, et cetera. Like, and make it simple that everybody understand.
Yeah. I would say the most important for every startup, the most important data related topic is not to hurry with and not to rush with building a data warehouse, because data warehouse is good for having a single source of truth. But the thing is that data warehouse um, needs to be built in time. It should not be built too early, because at the early stage, data models and data structures change too frequently. And it's better to connect. I know such examples. For example, I was working as a consultant with one cryptocurrency company, and they lived more than 3 years, I think, without any single sign of data warehouse. And all of their analytical processes were just connected to a replica of production database, and it was totally fine. I think that's exactly the right strategy, because if you start having one single source of truth too early, you will simply do double work with changing the structure in many places and trying to keep it in sync. So I
So
think that's, yeah.
so just bring it as a milestone. If we run a company, start a company, don't over engineer, keep your single source of truth as a production database. So let's in our case it's a Postgres. So this should be things we gonna be evolving from. So this is our baby, and from that baby, the baby will grow. The baby will get, I don't know, maybe more hands or something else. But essentially, should be like a starting point. So what we establish a
Yeah.
business, we get first transactions, we invoicing our people, our clients. Next, what is the next step? By the way, what is the data warehouse and data lake like? Just let's explain that to the larger audience.
So basically, at the very beginning, as you described, um, most of the valuable data will be stored in our production database that is connected to our, I don't know, fintech platform or e-commerce platform, whatever we are building. So basically all the data that is produced by our customers and the system itself will be stored there. And at the very beginning, we will be very interested in having an instant access to this data and minimizing a gap between the time when this data was produced and the time when we can react on it. So that's why it's also more productive to just connect our BI software, whatever we have, to this production database. But the next step, of course, when the company will evolve, we will start having more complicated use cases. We will need at some point such things as predictions. We will need more extended reports, graphs. We will need definitely such thing as a separation of concerns, different permissions for different users, and stuff like that. And the most important thing for all of that, we will at some point need a different structure of data. And that's the key difference between a production database and a data warehouse. For example, analytical SQL requests, SQL queries can be slow because no one needs them to run like this as fast as possible. It's fine that they are heavy. It's fine that they're slow enough because you don't need to run them too frequently. You just run it from time to time, build all of your graphs and reports, and forget about it. But the SQL queries, for example, that are used in your application needs to work as fast as possible because they serve customer experience. Customers should not wait. Customer is king, so customers should always be served as fast as possible with data. So that's also a point where we start having these different needs for different structures, and that's the point when we build data warehouse.
So the second milestone in our business with you, Artyom. So we've established a single source of truth. This is our production Postgres. This is where, like, where we send the invoices, all the business logic happens. And we grew to the size that we need to analyze that, but analytical queries are too slow, and we don't want to run them on the production database. So we would create a larger replica of our database on the side. We call this data warehouse, and this is where all the analyticals heavy work is happening. Correct?
Exactly.
And what tools, like, I know we call it like ETL, extract, transform, load, is used? Do you need to use them? And most importantly, at which layer of this transformation we could apply a vitamin that is called Datamin. So Datamin, your company.
Yeah. So basically, such thing as ETL will definitely be needed for that, because simultaneously with all these needs that we just discussed, we will start having a need to copy data from different sources. It's not going to be just our production database anymore. We will need data from such tools as Segment or Google Analytics, or maybe such invoicing software like Stripe or payment software like Stripe. We will start having a need to get some customers' data from, for example, if we at the same time have a mobile application, we will use such software as an apps flyer to collect this analytics. And we will also need to bring all of that into one single source, one single storage where it can be merged with each other for analytical purposes. And that's what we will need ETL for. So as soon as we have all of that in place, as soon as we have data sources where data is created, we have ETL which copies this data from the place where it's created to where it's stored and used by BI software, by data scientists, by data modeling, and so on. Answering the question about the place of Datamin for that, it can be both, actually. It depends on the needs. The natural design of how Datamin is built and the problems based on which it was built, it allows Datamin to connect directly to production database or a closest replica of this production database. Because one of our main USPs and one of our main purposes, values that we give to our customers is exactly an ability to react and automate this reaction on the data as soon as it's created, not as soon as it's copied to data warehouse after some time, because this time can be even hours, and for some types of data it's already a critical gap, because it can either produce some damages if data is broken, or if data is I don't know incomplete, and it can affect customers. So that's why what we recommend is to connect Datamin as closer to the place where data is created. But at the same time, it can also be connected to a data warehouse or any API if necessary. We have such use cases as well. We have customers who don't connect it to their primarily sources of data. They connect it directly to various APIs of software that they use, like Salesforce or HubSpot, because they have a lot of valuable data there, and it's not yet in their data warehouse.
So let me rephrase it. So in our business with you, our Postgres production database is able to send just-in-time data to Datamin, and Datamin enables operational team to instantly respond on any changes that could be triggered in the production database.
So basically, it's more like a pool. In case of Postgres, it cannot send data to Datamin, but Datamin can pull data with a certain frequency from Postgres. But if we really want to push data to Datamin, and that's what we also recommend for such time-critical data, we encourage customers to use Kafka integration with Datamin. We have this open source library that we built for that, and basically they just need to install this library into their Kafka cluster, and then Datamin will be used as one of the consumers of this data, and Kafka can push it directly to Datamin.
So there are a few event bus services. Kafka is one of those. There's SNS and KNS produced by Amazon Web Services. Just to stay like a bird view, what is Kafka? What is the event bus? How do we use them, and do we need them at all?
So basically, this is, I think, a separate topic, quite a broad one, about what kind of event buses or pub/sub technologies are on the market and how it's used, starting from such ones as RabbitMQ, ZeroMQ, and so on, and then Kafka. So basically, in a nutshell, the idea of event buses is to distribute data actively across different consumers of data. For example, if a piece of data is created in one place, it can, using these event buses, it can be instantly delivered to various microservices or APIs or any other consumers of this data without the need to pull it from a data storage, which makes it real time, so, or as close to real time as possible.
So to bring this analogy for non-technical audience, we could imagine that events are passengers, and the bus station is basically a Kafka that distributes people in the buses to different destinations. So somebody might drive to Hamburg, somebody need to drive to Warsaw, and there they will be treated in a different way. And this is where they're most needed. And the Kafka is, in our case, Flixbus bus station.
Yeah,
Can we use this analogy?
yeah. With the even better feature that in case of such services as Kafka, one passenger can be delivered to Hamburg, London, Berlin, Madrid at the same time.
Flixbus teleport.
Yeah, exactly. And that's why, for example, it's an advantage of Kafka, so that you can just use Datamin as one of the destinations together with the rest of destinations that you already have in your Kafka environment, or any other even bus service. So you just plug it as the next Amsterdam or Hamburg to your Kafka cluster, and then the message gets delivered there.
Artyom, if we going back to being data driven, what do you think is important for us again? So our startup, we still, operating in this realm of our startup. How can we build a culture of everyone in a company to be really data driven? What do we need to do? What we should not do at all? And yeah, like let's write a script for that.
That's a very good question. That's a very good question, exactly, because I think we all, like everyone who was working in startups for the past 8 to 10 years, we all can see this evolution. All of us could see this evolution happening on our right in front of us. Um, like if I take an example from 8 years ago when I was working at Funding Circle, a British fintech unicorn in Berlin's office. When every time when we needed some data reports or we needed some graphs or tables, we um, had a special BI department for that, and all the business users in the company, they went to BI people with their tasks, and they created these reports for them, which of course was from one perspective good because there was one single point of truth. On the other hand, it was slow because when everybody goes to the same person, this becomes a bottleneck. Uh, if I look what happened at Beely, my next company in fintech, like 3 years ago or 4 years ago, our product managers were already able to write complex SQL queries to retrieve data on their own. Um, at the same time, they also had their own access to business intelligence platforms and built dashboards for their own. Our CEO even started to learn SQL in order to also be much more data driven, let's say, in his decision making. So this is what data driven culture is, when every single department in a company, no matter if it's engineering or sales, uh, have enough access and enough knowledge to data and can basically operate with this data in order to make their data driven decisions. So I would say education is definitely a key here, but also software that allows this is super critical.
And to linger on that topic, you mentioned that in the past, one of the most advanced managers you work with, they already knew SQL, so they were like, diving in and they were typing their query and getting information out of the database. By the way, the SQL or SQL, it's a structured query language, also invented in 70s and used as a standard way to operate directly from your database. And Artyom, with your invention, actually not invention, with your integration of ChatGPT into data modeling, would you recommend our kids to learn SQL, or they could just operate with like natural language commands, like give me the list of users with the name starting A?
I would say that's another critical problem that's still not solved, and there are companies who are trying to solve it by years already. Um, so the problem of converting a natural language to reports or graphs or dashboards. And I still recommend to learn SQL, at least on a basic level. It's very simple. It's also close to a natural language in the end, because if you just need to retrieve data, you write select types of data that you need from the table, done basically. So I would still recommend people to learn it in a certain level required for their job, because the evolution of AI being able to do that is still not there, and it's still coming. And the main obstacle here is that even inside the same company, one term can mean different, uh, can have different meanings for different departments. The classical example, if we take a word revenue and ask CFO, sales, CEO, and data people, what is our revenue and how we calculate it, they will give you different examples, because for them, revenue is different for their daily routine. That's why, of course, if every of them write this natural query to the database, they might get not what they expect to get.
But like just to push back on that, it's quite challenging. Even if, well, at least in every company I've worked with, you join the team and there is already established data architecture, and you know your SQL, so you try to connect. So first of all, you're not going to get access unless you go through, I don't know, you need to get access. So you would spend some time getting this access to a replica of a database. And even if you have access, but you don't understand the schema, it's going to be very hard for you to type any query, because like if you select from, and then to explain to our audiences, when we type select from, and then normally we indicate from which table we would like to read out data. And if you don't know the table name,
Mm-hmm.
it would be impossible. So first you need to get the schema, and if you don't have this view from the normal user, you will get errors all the time. And
Yeah,
I
yeah.
and also my question, our company that we just established with you, we still operate in the realm of Artem Sergey company. We are very small, so I have access, you have access, we know our tables, we know the schema, and then our team is growing. Like we have like 5 people that we just hired, and we want everybody to be data driven. What shall we write in our script, operational script, for them to have this literacy to understand how the data is stored and to what level it's needed?
Um, yeah, I think the key here will be to prepare some kind of a middle layer between the raw data and the data that can be used for their needs. So such companies already exist. Basically, the companies who are trying to solve this problem, when um, it's basically a part of the data mesh concept in general. So data mesh is a concept where one of key features of this concept of building data-driven culture is that you have a central team that is responsible for master data. So basically the data, how it is coming, basically ETL, how it is coming to your data storage, data source of truth, how it is stored, how it is updated there. And then in every decision making team, either business or operational team, or it can be Scrum teams, or it can be Spotify kind of concept teams, tribes. So you have a person, either a data engineer or someone who is familiar with data, who is responsible for building a usage of this data and facilitating a correct usage of this data inside the team. So basically, these central people are not a bottleneck anymore. They prepare data to be used, and how it is used is decided by every single team in particular. So I would say, if we get back to our company, when we start growing, we need to either prepare this mid layer on our own, or at some point hire a data engineer to be responsible for that, and then delegate this responsibility of working with data and taking decisions to teams. We have this example in one of our current customers, actually. Um, the customers, they have approximately the same setup that I just described. and a company and a part of this company who is using us is not the central data team, but the decision making data engineers who work in operational departments. So that already shows how it theoretically can work in practice.
Now the questions from the realm of engineering managers that I always face. You've mentioned this cross-functional teams or Spotify structured teams, so where you have several verticals, and each engineering vertical is focused on specific business domain, and how important it is to integrate data people in those teams, or you believe it's actually, there are places somewhere else they have to be sitting in the closed room outside of the squad structure. And I don't know, like, what is the best team setup from data view?
I would say it exactly depends on the if the company has grown to this point where this such distribution of data knowledge between different cross-functional teams is needed. So probably when we talk about our small company that you and me built, then it's not yet there. It's unlikely a company that is smaller than 50 employees, for example, needs something like that. A central data team can easily do this job for the entire company. But if the company grows significantly, passes, let's say, their round C, Series C round, and started to go towards a small enterprise size, then definitely it's a time when data team will become a bottleneck. And if the company follows a cross-functional team concept, either Scrum or Spotify way, someone can be responsible. It's not necessarily a data engineer that is integrated into a team. It can also be a software engineer who is familiar with data. It's more like a function, let's say, that can be assigned, not a title of a person.
Artyom, are there any companies that you looking up as role models, like, or companies that by looking at data management and data architecture, you would say, okay, I could learn a lot from these guys, and I recommend you too as well look at their best practices?
Mm, yeah, I would say from the perspective of companies with whom I worked and or basically whom I know personally, I would say one of the good examples is definitely Stripe, and also SumUp. One level down, basically, because SumUp is quite a big company already, and they have their own challenges and problems. If you come a bit down towards smaller companies, SMEs, then I would say one good example is Volt. This is a company, I mean, Volt with V, not with W, a British fintech company where they have a very good structure of data teams, and their data analysts, they work together with operational teams. And this is a good example that people can take a look at.
And again, staying operational, you mentioned companies with a very microservice heavy architecture where you require basically on the instant level to process and send different services from different business domains, aggregate and the like. And what is the best practice in terms of the setup? We're still small, like your and mine company. We're small. We just added another microservice, and we might plan to add another microservice. Should we keep our data separated? One, each service should have a different database. Like, what is the best standard in that regard, and how to handle that?
Yeah, if we talk about microservices, definitely they should have an access to only their database. And one database should work with only one microservice by the pattern definition. Otherwise, it's hard to maintain. It's quite hard to maintain scalability of such services, let's say, because if the team grows, then at some point different teams inside the same organization start being responsible for their microservices only. And if two microservices maintained by two teams have access to the same storage, it brings exactly the same problem as a big team working with one monolith. So that's exactly the problem that many companies starting to face. And if we talk about sum up, that's what I also know from them. At some point, they started to duplicate data simply because to avoid a few microservices being connected to the same storage, they started to duplicate data and distribute it between different databases, which is fine, which is good. It has nothing bad with as a concept, as soon as these data are consistent, so that you don't have like a slight 5% difference between the same pieces of data stored in different databases. Then it will be a huge problem. But if it's possible to avoid it, then why not?
Do you have your favorite database that you use in every project?
Uh, well, I would say the majority of companies I've been working in, I was using MySQL, but not the MySQL itself. It was always Percona's version of MySQL, because Percona, they improved a lot in terms of scalability and productivity of MySQL. And since 2011, I think I was using Percona very actively. Although nowadays MySQL itself uh, is already much better than it used to be in terms of indexing, in terms of performance, in terms of access to data. So I was always skeptical, let's say, with the wordings when people said that MySQL is a bad database for big data. And to be honest, I never faced a problem with MySQL when we could not scale it anymore. And uh, I was working. I was building from scratch one social network that reached 10 millions of users, and we were still using MySQL with replication and sharding, and we were quite happy with that.
Well, by the stats that I've checked yesterday, MySQL is still leading database, at least by the, in the e-commerce and the PHP users, which heavily operate on e-commerce. MySQL is still leading. Uh, why Postgres became so popular? Is that open source, or there is another secret sauce that plays into this game?
Yeah, I think in general, Postgres was mm, open source is a huge factor. So the community that was maintaining Postgres played a huge role there. But also in terms of performance and productivity and flexibility of what you can do with Postgres was always higher comparing to what you can do with MySQL. I think this was a secret sauce of these two factors was always secret sauce of their popularity.
And to wrap it up, I was like, I was in Hanover at the party organized by a friend of mine, and there were a lot of old school engineers that were, well, they are professors now, and they were working in the 70s and 80s back in Russia, and I was asking, was there an answer to big databases that and because we came to conclusion that everything computer related that is operational and commercial came from United States. So it started like as a this hierarchical database. This then there was like the whole evolution, and it
Yeah.
was always like that. And I've been curious because like if we look at the German realm, we have SAP and their HANA as a competitive product. but Oracle is still dominating. Oracle and Microsoft are still dominating enterprise sphere. And just your view on that. Do you believe that we might have some kind of, I don't know, underdogs coming from unknown countries and creating something interesting, or it's still going to be the space and domain of American enterprise companies?
I would say, surprisingly, even if a company is American, there are a lot of European companies in the reality. So the companies are European, but nowadays they are in the US, especially if we talk about data space. So such companies as Good Data or Manta, both of these companies who are currently operating. Good Data is an embedded analytics company, one of the fast growing leaders of the market. Manta is a data lineage company. Both of these companies are coming from Czech Republic, and both of these companies are nowadays American. And there are a lot of examples like this. If we talk about data observability space, uh, of course, there is a huge leader called Monte Carlo Data, which is far in front of any other company. That is US based company, but the company is coming from Israel. And their one of their new competitors, Validio, that recently raised a huge round with a participation of Zlatan Ibrahimovic as one of the business angels. The company is from Sweden. So it shows that a lot of companies are not actually Americans, but they are coming from uh, Europe and Middle East, and there will be for sure more and more with the current level of globalization on the market. Definitely, the world becomes more and more cross border,
I,
and in
I,
data space in particular.
I love your example that Ibrahimovic is so data driven that he invested in the data company. And
Yeah.
also my example, I've been integrating analytics and the web app today, and we are not fully compliant with Google Analytics, so we decided to go with Plausible, the company from Estonia that offers like really lightweight analytics, and the script size is just below 1 kilobyte, which is like it doesn't affect you the page loading speed. And I
Hmm.
really wish that we all are going to be more data driven on a day-to-day basis, and more companies like yours, that we will have more vitamins and data means around there. And yeah, and just good luck with your company, and looking really forward for all the new features that you're about to release. Thank you very much, Artem, and have a nice day.
Thank you, Sergey. Thank you for all the warm words and for this extremely useful and great conversation. So have a great day too. Thanks everyone for watching this, and bye bye.